Here is your video for two sample z-tests for proportions. We will be comparing two population proportions, very similar to what we did before when we compared two means, and we will do inference as well as confidence intervals dealing with those types of questions. So the first thing we start off with are some new formulas. Now for a confidence interval, all right, the formula for a confidence interval for the difference of two proportions is going to be p hat 1 minus p hat 2 plus or minus z star times our standard error formula, which is p hat 1 1 minus p hat 1 over n1 plus p hat 2 1 minus p hat 2 over n2. Not that bad, and it's on your reference sheet, so there's some help there. Okay, so that's for a confidence interval for a difference of two proportions. Now for the formula for a hypothesis test, which does become a little bit more challenging. So it says z, which is nice, so we don't have to worry about that. P hat 1 minus p hat 2, again the difference in sample proportions, minus p1 minus p2, which again we're going to follow that same format and say that we're testing to see if these two things are different, and the null hypothesis will be that they are same. So that's really just going to be 0, and again you'll see that. Okay, over this standard deviation. Now we have a new formula for standard deviation. It's going to be p hat 1 minus p hat over n1 plus p hat 1 minus p hat over n2. Now, what you'll notice is, and I did not make a mistake there, is that there's p hat 1, there's p hat 2, and then there's plain old p hat. Okay, so like I said, that does make it a little bit more challenging. So p hat, in this case, is combined. We're going to call it a pooled p hat. And basically, we're assuming that the two sample proportions come from the same population and that they are equal. So we're going to use this special combined p hat, which is just successes from the first population plus successes from the second population divided by n1 plus n2, which is, it will give me my total sample. So I do have to do this other calculation there, and it's not hard, it's just tedious. Okay, so the last thing that I'll write down are the hypotheses. So again, your hypotheses are either going to be P1, well actually, I'm sorry, H sub 0, P1 equal P2. That's always going to be your null. And your alternate hypotheses is either going to be P1 less than P2, P1 greater than P2, and of course the two-tailed hypothesis P1 not equal to P2. Okay, so let's walk through an example, talk about this pooled p hat, and move on. Some researchers and privacy advocates are concerned about the possible access to personal information about teens in public places on the internet. There appear to be differences between boys and girls in their online behavior. A survey was conducted in which teens aged 15 to 17 were asked if they had posted online profiles. 142 of the 248 boys had posted profiles, compared to 179 of the 256 girls. Is there evidence that girls are more likely to post profiles than boys? Okay, so we're going to go through and label all our variables. Okay, there's for the boys. So that's going to be p hat of the boys. I'm going to use a capital B, which is 142 divided by 248, which is going to give me 0.57. All right. P hat for the girls is 179 divided by 256, which is going to give me 0.70. All right. We have n of the boys, which was 248, and we have n of the girls, which is 256. Now, off to the side, we're going to calculate this combined pooled p-hat. Okay, and it's pretty simple. It's just a little tedious, as I said before. So there were 142 of the boys that said they had posted online profiles, plus 179 of the girls that had posted online profiles. There were 248 total boys and 256 total girls. So that's really giving me my overall percentage that have posted an online profile out of the entire sample. So with a little bit of math there, I get 0.64. Okay, so that's all I really need to answer these questions. Okay, we're going to start off with the hypotheses. Okay. Null hypothesis, T sub B equals P sub G. And the alternate hypothesis, P sub B is less than P sub G. Girls post online profiles more than boys. Okay, we have to identify what our parameters are. P sub B is the proportion of boys with online profiles. Okay, and P sub G is the proportion of girls with online profiles. Okay, so there's our hypotheses. We're a quarter of the way done. All right, next we move on to our conditions. Okay, you got to check both. And again, that goes back to we're doing two independent samples, so we have to check that both meet the conditions. So our first condition is an SRS. Okay, so both samples randomly selected. And that's stated in the problem. Okay, we've got normal. Now, this is a little annoying, but not difficult. We've got NB times P hat B greater than or equal to 10. NB 1 minus P hat B greater than or equal to 10. We've got NG P hat G greater than or equal to 10. And NG 1 minus P hat G greater than or equal to 10. So I essentially have to check that for all of them. So I'm just going to use what I copied down from here. All right, NB, so 248 times 0.57. And 248 times 0.43. That's 1 minus, and both of those are over 10. 248 times 0.57 gives me 141.36. 248 times 0.43 gives me 106.64. Both of those are good. I'm going to write in a different color over here. So we have 256 girls and 70%. So 256 times 0.70 equals 179.2, and 256 times 0.3, 1 minus, which gives me 76.8. Okay, and then the last one is that the two samples are independent. samples are independent of each other. Remember, I don't have to do the population greater than or equal to 10 n here. I can just say that the two are independent of each other. All right, your favorite part, my favorite part, the calculations. Okay, so first off, we're going to write our formula. Z equals P hat B minus P hat G, over the square root of P hat 1 minus P hat over N1 plus P hat 1 minus P hat over N2, again, where P hat is that combined or pooled proportion. Okay, so we've got P hat B, which was 0.57, 57% of the boys had an online profile, minus 70% of the girls had an online profile, divided by the square root of P hat, which we calculated off to the side up here, that pooled the proportion, which was 64%. Okay, so 64 times 1 minus 64, which is 36, over our N1. I'm sorry, this is NB, and this is NG. Let's see, 248 and 256. 248 plus 0.64 times 0.36 divided by 256. Okay. I'm going to get negative 0.13 up top. And on the bottom, again, I'm just going to type that in my calculator just as it is. I get 0.0428. I divide those two, and I get a z-score of negative 3.04. Okay. Normal CDF, that's nice. I can use normal CDF because this is a z. Normal CDF, I'm testing less than, so negative 1 and a bunch of zeros, negative 3.04, and that's going to give me a p-value of 0.0012, which is my p-value. And now we get to the conclusion. So, same overall process. We got a few new things. Let's use alpha equals 0.05. Okay, we will reject the null hypothesis PB equals PG at alpha equals 0.01 significance level. Since our p-value is less than alpha. So again, that's 0.0012 less than 0.05. We have evidence to conclude that girls post, let's just go back up to the question just to make sure, are more likely to post profiles than boys. Girls are more likely to post profiles than boys. Okay, so again, we continue this same overall process. Condition or hypotheses, conditions, calculations, conclusion. The main difference here is that we have a slightly different formula and that we're using a pooled p-hat in our calculation of standard deviation.